Hello everybody, welcome back. This is section 2.4 in unit 3, and we are talking about deductive reasoning today. Now, in the last class, we introduced and talked about inductive reasoning, and we defined inductive reasoning as creating a conjecture or making a conclusion based off of observations or patterns. And we talked about how do you know which side of the stairwell to walk up or down during the school day when the stairwells are crowded. And we all agreed that based on the observations that we have day in and day out of walking up and down crowded stairwells, we should walk on the right side of the stairs. This is what we would probably consider a social or cultural norm. Nobody told us that we had to do it that way, but we observe a pattern every day, and we conclude that that pattern will continue. Now, how is inductive reasoning different than deductive reasoning? Well, deductive reasoning is the process of showing that certain statements follow logically from agreed upon assumptions and proven facts. In other words, inductive reasoning is finding a result based upon a pattern, and deductive reasoning is proving that something is true based on facts. So one area of mathematics where we apply deductive reasoning is algebra, right? Algebra is deductive reasoning because everything we do in algebra, every step in solving an equation, is based on the facts of algebra. You are allowed to do some things, and you are not allowed to do other things. So here's an equation, and we're going to solve it for x, right? So this is very much a like an Algebra 1 or maybe Algebra 2 problem. But what we're going to do is we're going to provide the explanation for why we're able to do each step. So the first step that we would do here is we would distribute the 3 and the 2 to what's in parentheses. So we would get 6x plus 3 plus 4x plus 2, and then I'll just rewrite the plus 7, and I'll rewrite this over here, and then I'm going to write that we were allowed to do this because of the distributive property. All right, that's the algebra fact that says we could do what we did. Now, the next thing that we're going to do is we're going to combine like terms on the left side. So 6x plus 4x would give us 10x, and 3 plus 2 plus 7 would give us positive 12. And I'm going to rewrite the right side. And what are the algebra facts that allow us to do this? Well, you heard me use the phrase combine like terms. And in algebra, we know that variable terms, like the x terms, are like terms, and constants, like the 3, the 2, and the 7, are like terms. So based on those facts, we can combine those. All right, the next step is I'm going to collect my x terms on the left side and my constants on the right side. So I'm going to add 5x to both sides. And I'm going to subtract 12 from both sides. So 10x plus 5x gives me 15x. The plus 12 and the minus 12 cancel each other out. Over on the right side, I have 42 minus 12, which gives me 30. And the negative 5x and the positive 5x cancel each other out. Now, the algebra facts that allow me to do this are called the addition property of equality, which says I'm allowed to add the same thing to both sides of an equation, and the subtraction property of equality, which says I'm allowed to subtract the same thing from both sides of an equation. Now I'm down to 15x equals 30. My next step will be to divide both sides by 15 to get the x by itself. 15 over 15 is 1, so we get 1x equals 30 divided by 15 is 2. So what was the step there, or what were the algebra facts? Well, we divided both sides of the equation by 15, and this is called, you guessed it, the division property of equality, which states that we are allowed to divide both sides of an equation by the same thing. So we have solved this equation. We have figured out that when the variable x equals 2, we will satisfy the original equation. And we've done this based on the facts of algebra. Let's look at another example of using some inductive reasoning before we look at some more deductive reasoning. In each diagram, ray AC bisects angle BAD. So you can see on the left, we have angle BAD bisected by ray AC. And in the diagram on the right, we have a different angle BAD being bisected by ray AC. Classify angle BAD, angle DAC, angle CAB as acute, right, or obtuse. Make a conjecture and then justify your conjecture. Okay. So let's start over here on the left, right? We have angle BAD, and they're telling us that it equals 100 degrees. So obviously we know that angle BAD is obtuse because it's greater than 90 degrees. Now, angle DAC, right here, this angle DAC, we can see, we can see it looks like that angle is definitely less than 90. So we would see that we would say that angle DAC is acute. Next we look at angle CAB, so this angle here. And that angle certainly looks less than 90 degrees, so we would also categorize that angle as being acute. So we started with an obtuse angle, it was bisected, we got two acute angles. Now let's go over to the right side, to this diagram, angle BAD. We can see that it measures 162 degrees, and so that also is obtuse. It is being bisected by ray AC right there. And let's categorize. Angle DAC certainly looks to be less than 90 degrees, so acute. And angle CAB, also less than 90 degrees, also acute. So again, we started with an obtuse angle, we bisected it, and we created two acute angles. So what would be our conjecture here? Well, our conjecture, it seems that there's a pattern here, right? That if we start with an obtuse angle and we bisect it, we will always end up with two acute angles, right? So let's say when an obtuse angle is bisected, the result is two acute angles. Certainly seems to be what we have seen here, right? Now let's look at the difference between inductive reasoning and deductive reasoning. On the previous slide, we just saw that we used some inductive reasoning to create a conjecture, to discover a property, that if we take an obtuse angle and we bisect it, we will get two acute angles. But how does deductive reasoning play into this? Well, think about this. We took two examples and we'll now try to apply this to all obtuse angles. How many different obtuse angles are there? There's probably only an infinite number of obtuse angles. So how can two examples represent all infinite number of obtuse angles? That seems a bit extreme, right? So let's apply some deductive reasoning. The definition of an obtuse angle is that it has a measure, m, that is greater than 90 degrees and less than 180 degrees. Now, if we bisect this obtuse angle, that means we're cutting it in half. So let's take the measure of this angle and let's multiply it by 1/2, right? We're cutting it in half. Well, if we multiply the measure by 1/2, then we have to multiply every part of the inequality by 1/2. Well, now let's do some simple multiplication. Our measure will now be less than 90 degrees because 1/2 of it, 180, is 90, and it'll be greater than 45 degrees. Now, by the definition of an acute angle, we know that all angles that have a measure greater than 45 and less than 90 are acute angles. Therefore, by using deductive reasoning and the fact that our variable m can stand for any obtuse measurement, we have used some algebra and deductive reasoning to conclude that for any obtuse angle, when you bisect it, you will get two acute angles. This shows the value of deductive reasoning and the value of algebra for that sake, because instead of needing to come up with an infinite number of examples using inductive reasoning, we can sort of account for all infinite number of obtuse angles by using algebra and that variable m right there. So this gives you an introduction to deductive reasoning, right? Drawing conclusion based on facts and how it's used some in mathematics and geometry. We will take a very closer look at deductive reasoning in class.